Hi all, welcome to Anil Nair classes YouTube channel. In the previous video, I discussed how to find out the fifth root of a perfect fifth power. Fifth root of a perfect fifth power. In my previous simplification problems, I discussed the concept of a nth root of a perfect nth power, but it is not mandatory that all the problems will be of perfect squares, perfect cubes, perfect fourth powers and everything. Now in this class we are going to discuss the approximate value. We are going to discuss the approximate value of a non-perfect nth powers. Extremely interesting logic. Non-perfect nth powers. What does that mean? That means how to find out the square root of 29. Square root of 29. Definitely it is a non-perfect square. It is a non-perfect square because a perfect square always has a digital sum 1, 4, 7 or 9. But the digital sum is 2. So how to find out the approximate value of a non-perfect square? Suppose for example, cube the root of 13. Definitely it is a non-perfect cube. Non-perfect cube. Why? Because a perfect cube digital sum. A perfect cube digital sum will be only 1, 8 or 9. Or probably it is 921. Definitely it is a non-perfect fifth power. Non-perfect fifth power because a fifth power will never have digital sum 3 or 6. A fifth power should not have digital sum 3 or 6, and the digital sum of these number it is 3. How to find out the approximate values of a non-perfect nth powers using the estimation technique? Using the estimation technique. First we will discuss a concept, then we will apply. First we will discuss a concept. Let there be a value capital A. What is this capital A? This capital A, it is nothing but non-perfect square or a cube or a fourth power or an nth power. A could be a non-perfect square, non-perfect cube and everything. Now I am applying nth root of A. N could be, right, a square root of a, if it is a non-perfect square, square root of a non-perfect square or a cube root of a non-perfect cube and so on and so on. Let these value nth root of A. Listen carefully, sir. I am applying power n. It is nothing but capital A. Nth root of A. This nth root of A, this will have two values. One is integer value just less than or equivalent to nth root of A. For example, root of 29. Root of 29, integer just less than or equivalent to root 29 is 5. So, or otherwise, cube the root of 13. Integer just less than cube the root of 13 is cube the root of 8. And there will be some value. That value I will call it as estimated value. I plus e power n. What is I? I is an integer just less than or equivalent to nth root of A. E is the estimated value which we need to find it out. E is the estimated value which we need to find it out. Once we get the estimated value, root of 29 is closer to root 25. Answer is 5 point something. What is that something we are trying to determine? I hope the logic is clear here, right? Now, A is nothing but I plus E power n. Let n equivalent to 2. If I take n equivalent to 2, I am finding the square root of a non-perfect square. This is nothing but I plus E whole square. This is nothing but I square. Next is 2 into I into E plus E square. E is an estimated value. D is nothing but estimated decimal value. Some points it will be there. I is an integer, bigger value, very small value. So I can eliminate it. E square, estimated decimal value on square, right? It is a very smaller value. A is very close to or approximated to I square plus 2 into I into E. So A minus I square divided by 2 into I, this is the closest estimated value. This is the closest estimated value. For example, I am finding the square root of 29. Square root of 29. If I call this as A is nothing but I plus E. I is an integer just less than or equivalent less than root 29, root 25. So it is 5. 5 plus what is an estimated value? This is nothing but this is A equivalent to root of 29 whole square, I plus E whole square. From there, what is that we got it? This is nothing but 5 plus A is nothing but, right, I plus E. 5 plus what is the difference? Root 29, root 24. 4 minus, I hope the idea it is clear, or I will write like this. This is nothing but 29 minus 25 by 2 into I value it is nothing but 5. So 5 plus 4 by 10. This is what the answer is. I hope the idea it is clear. A is I plus E power n. So A is nothing but these A is approximated to, E is approximated to A minus I square divided by 2 into I. Let me take one more example, then you will be able to understand it clearly. A is I plus E power 3. I is an integer. A is I cube. Next it is 3I square into E. Next it is 3 into I into E square plus E cube. This is an estimated decimal, very small. So A is very much close to I cube plus 3 into I square into E. So estimated value it is given by A minus I cube divided by 3 into I square. I hope it is clear, right? A minus I cube divided by 3 into I square. Suppose for example, we require cube the root of 13. First thing, D is nothing but, A is nothing but I plus E. What is the integer just less than cube the root of 13? Cube the root of 8. 2 plus cube the root of 8, cube the root of 13. What is the difference? 5. A is nothing but, right, A minus I cube. I hope it is clear, right? So a 13 minus I cube, it is 2 cube, 8, it is 5, divided by 3 into I square, 2 square. I hope the answer it is clear. So 2 plus 5 by 4 3s are 12. So answer is very close to 2 5 by 12. Answer is very close to 2 5 by 12. I hope the idea it is clear. Now we will also do one more problem. Cube the root of, for example, 41 it is there. Step number 1. Cube the root of 41 is just less than cube the root of 27, which is nothing but 3. Answer will be just greater than 3. So this difference 14 divided by 3 into I square, 14 into 3 square. This is nothing but 3 plus 14 by 27. I hope the idea it is clear, right? Suppose if it is A equivalent to I plus E power n. Suppose if I take n value 5, this is nothing but I plus E power 5. So this is nothing but I power 5, integer power 5, 5 into I power 4 into E. Estimated decimal values will increase. These are all very approximated values. So A minus I power 5 divided by 5 into I power 4 equivalent to E. What is E? E is an estimated decimal value. I hope the idea it is clear. Now you can find out the approximate value. Now you can find out the approximate value of a non-perfect square you can find, non-perfect cube you can find, non-perfect fifth power also you can find it. I hope the logic it is clear. Let us take an example of fifth root of 93. Digital sum it is 3. It is a non-perfect fifth power. So 2 power 5 it is 32. 3 power 5 it is 243. So nearest value it is fifth root of 32. It is nothing but 2. I hope it is clear, right? So these are nothing but, what is an estimated value we got? A minus I power 5 divided by 5 into I power 4. A minus I power 5 divided by 5 into I power 5. These is nothing but 93. These is nothing but 32 divided by 5 into 2 power 4. These is nothing but 61. 16 5s are 80. So answer is nothing but 2 plus 61 by 80. 61 by 80. If I approximate it to 2 plus 60 by 80, 2 3s are 2 4s are. So approximately it is 2.23 by 4. 3 by 4 convert it into a decimal value. I hope the logic is clear. I will sum it up in a single problem. A is nothing but A minus I square divided by 2 into I. If it is for a non-perfect cube, A minus I cube by 3 into I square. If it is for a fifth power, A minus I power 5 divided by 5 into I power 4. From where we got all these three, A is nothing but I plus E power n. I plus E. What is I? I is an integer just less than or equivalent to nth root of A. What is E? E is an extra decimal value that we need to do it. A is an extra decimal value that you need to do it. I hope the idea it is clear. Suppose if somebody asks you, suppose 7th root of 131 he is asking. 7th root of 131. How will you do it? 7th root of 128 it is nothing but 2. So 2 plus 131 minus 128 it is 7. 7th is nothing but 7 into 2 power 6. Why? Because A is nothing but I plus E power 7. So these are nothing but I power 7. 7C 0. I power 7. 7C 1. I power 6 into E. E is approximated to A minus I power 7 divided by 7 into I power 6. I hope it is clear. This is how you can find the approximate value of a non-perfect square, non-perfect cube, non-perfect nth root. Please watch the previous video and this video. The idea will be extremely clear to you. In case if you enjoy the video, kindly like the video and share this video with all your friends who are finding it difficulty on how to find the approximate value of a non-perfect nth power. Don't forget to subscribe to our YouTube channel to get all the latest Anil Nair's concepts and shortcuts. In case if you want to buy the Aptitude course, you can always WhatsApp our official number 80500678991 to know more about the program details. Thanks a lot for watching the video. With love, Anil Nair.